Hi guys, for today's lesson we're going to be dealing with solving logarithm equations. So the first word to remember when we're doing this sort of skill is what the change of base formula is. So the change of base formula is a formula that allows you to convert any logarithm base to base 10. So your calculator can deal with it, because remember your calculator likes to deal with base 10. So if you've got some sort of expression like log base 5 to the 4, you can deal with this formula right here to change it up, so instead you have base 10s, which your calculator can use. So the idea is this. So the log of any base a, we can literally change the base to any base we want. B, for example, that b could be anything. But you've got to make sure that you're taking the log of x and dividing it by the log of whatever this a was. So pretty much you're changing this sort of thing to a fraction, both top and bottom having logs, and the x goes up the top and this base a goes down the bottom. And we can change this letter to 10 if we wish. So for example, log base 5 to the 4, typically we couldn't figure this out in a calculator, but using this change of base formula we can. This 4 goes up the top and this 5 goes down the bottom. They each got their own log, and we can use base 10s, meaning we can put this into our calculator. So this is the same as log 4 over log 5, because it assumes the base 10 for the calculator, and that equals 0.86 to 2 decimal places. Okay, we can use this really handy fact to be able to solve these sorts of equations where x is a power. We call these sorts of things exponential equations, because exponent is another word for indices. So the idea is, with this sort of equation, we're trying to isolate the base with the unknown power. So isolate this by getting rid of these two numbers, and then we can rearrange using logs. Okay, so the idea is we firstly get rid of this plus 3 by minusing 3 to both sides. Next up, we get rid of our times 200 by dividing by 200. And this gets this sort of equation. Now we've isolated our base with our unknown power. We have to rearrange this using logs. So our unknown power becomes the subject. Then our 2 goes like after the base, and our base of 5 goes down here. Now we've got to try and figure out the value of log base 5 to the 2. We can't do this in a calculator, but if we change the base to 10s, we can. So you've got to remember that 2 goes up the top, 5 goes down the bottom, each with their own log. And this in the calculator is log 2 over log 5, which equals 0.43, which is our desired value of x. Make sure you check it. You can put all this into your calculator with x being 0.43, and it should equal 403. Okay, question 2. Solve the following inequality. So we've got this inequality right here. We've got to think log 4 to the x has to be greater than or equal to 3. It's still about getting x by itself. The idea is that you want your x and your 3 to be staying on the same sides. They're not going to change. So your x stays on the left-hand side, your 3 stays on the right-hand side. They're not going to change, but your 4 will change to the other side, because the 4 is our base when we rearrange this sort of equation. So we get x is greater than or equal to 4 to the power of 3. 4 to the power of 3 is 64. So x must be greater than or equal to 64. Next up, solve the following exponential problems. We've got a few worded problems to deal with. Okay, so the population of a school of fish doubles each year. What I mean by doubles is that it increases by 100%. If the population is 200 now, so there's 200 fish at the moment, how many years will it take to reach 3,000? So the idea is we want to make an appropriate exponential equation. What I mean by an exponential equation is that we have a power which is unknown. The reason why we want to do this is because we consider this to be a sort of an exponential sort of problem, because we've got this doubling effect. So when something's increasing or decreasing by a percentage each year or after each time period, the idea is you're going to be getting some sort of unknown as a power. So the idea firstly is to make this desired equation, you have to think to yourself, well, firstly, we desire a population of 3,000, so that's our desired amount. So we'll start with that. We want that to be equal to, firstly, the initial amount of 200 fish. That's going to be the number that's timesing at the start. Make sure it's multiplying. Now this 2, where did we get this 2 from? The idea is, if something is doubling, that means it's increasing by 100%. So our original 100% of our population is increasing by itself, it's doubling. That gets up to 200%, which is the same as just 2. So therefore, that's where we get it from. It's coming from our doubling effect. And that percentage increase of 100% too, that is exactly what we need to power with an unknown power that is represented, that is representing time in years. Okay, so this is the equation we're trying to solve. So how do we solve this equation? Well, we got to isolate the 2 to the power of t by dividing by 200. That gets us 15. 2 to the power of t over here, we got to rearrange this to get our t as the subject. So t will stay on that side, the 15 will stay on this side, our base will come over here. So remember to keep the t and the 15 on the same side, but just move the base to the other side. You need to make sure you've got a log with your base of 2. And this is what we're trying to find the value of. That's the same as log 15 over log 2, changing the base to base 10. And that in a calculator equals 3.9 years. So it'll take approximately 3.9 years for that population of 200 to eventually get up to 3,000. So that's the sort of conclusion that you need to make. One more question. So the value of a car depreciates by roughly 15% per year. How long will it take for a $3,000 car to reach a value of $5,000, a $30,000 car to reach a value of $5,000? So again, this is the sort of question where a value is going down by a certain percentage each year or each time period. So this is going to be another exponential sort of equation. So our desired amount is $5,000. The initial amount is $30,000. Now, if you're going down by 15% per year, the idea is that your original amount, 100%, is going down by 15%. That's going down to 85%, and that's the same as 0.85. So that's kind of the sort of percentage that's found by finding a decrease in 15% of 15%. So that's the value here, and that is powered to the unknown variable, which is time in years. Okay, so how do we solve this equation? So the idea is we've got to isolate our base with our unknown power, divide by 30,000. 5,000 divided by 30,000 is 1/6. We rearrange this equation. The t becomes the subject, the 1/6 comes down, and our base is 0.85. We can't deal with this in a calculator, so change the base. The 1/6 is up the top, and the 0.85 is down the bottom, each with log base 10, and that gives us a value of 11.02 for time. So conclusion, it will take 11.02 years to reach a value of $5,000. Hope this working helps with the questions. Good luck.